Members,
Yes, teacher.
can we continue?
Yes.
All right. Now, which means our characteristic is what? Is negative.
-2.
Then our mantista is 0.95 what? 9527. So let me put it here. Let me put it here. This space is going to be enough. This space is enough. So now we shall have 2 bar, 2 what? 2 bar, point what? 0.95 to what? 27. Have you seen that, members? Have you seen that?
Yes.
So which means in standard form will be times 10 to the power negative, times 10 to the power negative 2. Then we get the antilog. Now we are getting the antilog, shift antilog of, we are getting the antilog of this one. We are getting the antilog of what? This one, the mantista, okay? Antilog of 0.95227. Members, have you seen that?
Yes.
Is what?
Yes, teacher.
Is 8.968. Okay?
Yes.
The power is negative. What does that one mean? Which means the number here is supposed to be 0. Supposed to be 0.0896 what? 68.
8.
Members, have you seen that?
Yes.
So our answer is what? 0.0896 what? 68. Can we prove our answer, members? Can we prove that?
Yes.
Let's prove. I'll start by dividing. So I will have 0.0189. I think that divided by 2.35. Are you together, members?
Yes, teacher.
What do you get? You get what? I think what you are getting on the screen.
Yes.
That one is only dividing, but now what are we left with? We are left with getting the what? The square? The square root. So what is the square root of that? The square root of the answer, what do you get? Is it not the one? Members, is it not the one?
Yes, it's the one.
Have you seen?
Yes.
So we are very correct. We are very what?
Correct.
Very correct. Members, I think you have understood logarithm now very well. Is there anyone who still challenge? Is there anyone who still challenge on how to handle logarithm? Or we add only one question and we stop there?
Yes.
Which question?
One question.
Now this one they will not set this kind of question. They will just put for practice because they are very lengthy. You can see this one how lengthy it is. Okay. Okay.
Yes.
Let's look for. Can we look at number 17? I think number 17, members.
Yes.
Yes, teacher.
Let's do number 17. Let's do number what?
17.
What is it saying?
17.
He's saying the square root of what? The square root of?
The square root
Of 12.81 over 33.6. 6. We know that this is the same as, that one is the same as
6.
Is the same as 12.81 to the power what? Not so? Now, members, this time the square root is only for the denominator. The square root is only for the what?
The numerator.
Takes note of that. Divide by 33.6. Now let's look at the solution now. Let's work it out. Let's what?
Work it out.
Out. As usual, what do we do first? We draw our table, right?
Yes.
You draw your table. Smart and organized. Smart and what? And organized. When you are smart, people will talk less about you. Okay? But should you be disorganized, my dear? The whole world will get to know you sometimes. People will even start asking you, and it's worse when you're a girl. People will even start asking, what does it stay? Who are the parents? So mathematics is for people who are organized and smart. Who are organized and what? And smart. So the first number is what? Our first number is 12.81. What is it in standard form? Is 1.281 times 10 to the power. How many steps have we moved? Only one step. Only one what?
Step.
So we shall have 1 point. 1 point. I think this, members, what have we discovered? Is it very easy to use a table or a calculator? But all are easy. All are what?
Easy.
So we are getting the what? The log of? We are getting log of 1.281. Okay? What have we got? 0 point? So we're going to have 107 what? 5. Okay?
Yes.
So that's the only number in the room. But that number has been raised to the power half. So let's first simplify that one also. So now we shall have now bring 12.81 to the power what? To the power half. So now that one, that's what we do. So which means it's going to be, we get the logarithm, which is 1.107 what? 5 times what? Times what?
A half.
Now members, the characteristic is what? Is a positive. The characteristic is what?
A positive. A positive.
Is a positive. So what do we do? What do we do? We divide it what? Normally. We divide it what? Normally. So we come and just put 1.107 what? 5 divide by what? Divide by 2. What do you get? We get 0.5.
578.
38. 38. Good. 38. We stop there. We what? We stop there. We come to what? Denominator. Our what? Denominator. Our denominator is what? 33.6. So what is 33.6 in standard form is going to be 3.36 times 10 to the power what? Remember, 10 to the power what? 1.
1.
So now this one will give us 1 point. 1 what? 1 point. So what is the logarithm? What is the logarithm of 3.36? Are you getting the same value like me? So we get 5, 2, 6, 3. Not so members.
Yes.
Is that in the number we have left out?
Yes.
Is that in the number we have left out? No. So I rule this one. We rule that one out like that. Okay? Members.
Yes.
Members.
Yes, teacher.
What do we do next?
We add.
From here we were what? We are dividing. We were what? Dividing. But what do we do to their logarithm? When we are dividing, we what? We subtract. We subtract, right? Let's subtract. Let's what? So I will have 8 minus, I will have 8 minus 3. What do you get?
5.
It give me 5. Then 3 minus 6. Is it possible?
No.
We come on board here. Here remain that one become 13. 13 minus 6?
7.
7. Good. Then 4 minus 2?
2.
2. 5 minus 5?
0.
Point. 0 minus 1?
Negative 1.
So it become 1 what? 1 what?
1 bar.
1 bar. So what does it mean? Our characteristic is negative what?
1.
So which means we come on here, right? Time 10 to the power negative what?
1.
Negative 1. Then we get the antilog of 0.0275, right? So shift antilog of 0.0275, like that. Okay? What do you get? Members, let's minimize noise. Let's minimize noise, please. What do you get? We get 1 point.
1.0654.
1.065 to 3 decimal places, okay?
Yes.
The power is negative. The power is what?
Negative.
So what does it mean? Which means this number is supposed to be 0 point. So it's going to be 0.1, okay?
Yes.
0, 6 what?
5.
6, 5. So then you come and we conclude. Now you close your table. You close your what?
Table.
So that's where the work is ending. That's to show that that's where the work is ending. Have you seen that? So you come and say, therefore, square root of 12.81 over 33.6. The answer must be what? Must be 0.106 what? 65. Are you together, members?
Yes, teacher.
Can we prove our answer?
Yes.
Pick your calculator. The first one is what? Square root, not so? Square root of, open a bracket, of 12.81. Close that bracket. Okay?
Yes.
Divide by what?
It's the 1.
Divide by 33.6. What do you have there? Is it not the 1, members?
It's the 1.
Please clap for yourself. Clap for yourself. Clap for yourself. You students, you are very good. Clap for yourself. Honestly, members, honestly now. Is there any question on logarithm?
No.
If I'm to be a radio, I think I'm very loud and what? Clear. Not so, members?
Yes.
Now, let's leave logarithm now because there is no question on logarithm that we have not yet tackled. All the question on logarithm, they are done case. Okay?
Yes.
So now what do I expect from you? What do I expect from you? Now, there are some questions we have left out here also. Now you sit down in your free time, practice them. Mathematics is all about practice. Mathematics is all about practice. Continue practicing. The more you practice, the more you gain confidence, and the more you discover your mistakes, and the more you become more accurate. Okay?
Excuse me, teacher.
Yes, please.
I had a question.
Yes, please.
Could you please repeat the conversion?
The what?
Converting our answer using antilog.
How we get it from the table or from the calculator?
From the calculator.
From the calculator.
Yeah.
Okay. So if you're using a calculator, you press shift first. You press what? Shift. I think that epido. You press shift.
Yeah.
Then log. You press shift, then log, like that. I think how is it going to display for you on the screen?
Yes.
So when it displays like this, it means you are getting antilog. It means you are getting what? The antilog. Antilog means you are getting back the real number. You are getting back the real number. Then you open a bracket. Like here, we are getting the antilog of 0.0275, like that. Then close that bracket. It will give you like that. Okay?
Okay.
Have you seen that, Epido?
Yeah, I've seen that.
Yes. You separate the characteristic from the mantis star. You are getting the antilog. You are getting the number from a log. So which means you separate the mantis star from the characteristic. Okay?
Yeah, I've seen it.
Very good. Members, I was saying, let's continue practicing. Practice, practice, and practice, and practice. Practice until you enter examination room. Practice until you enter examination what? Room. So let's go to, now let's revise now what? Let's revise. Good. I've changed even the booklet now. I've changed the booklet. Let's revise now what? Indices and surds. Indices and what?
Surds.
Indices and surds. Indices and what? And surds. Members.
Yes, teacher.
We noted down very many laws of indices and how we simplify. We look at simplification of surds. Remember, we look at what? Simplification of what? Surds. We discussed that. We have also seen how we rationalization of what? Surds. Okay. We have also seen laws of indices. Laws of indices and how and simplification of indices. Laws of indices and simplification of what? Indices. I think we still remember that. Do we still remember them?
Yes.
Now, members.
Yes, teacher.
I'm going to get question. I'm going to get question from the question bank here, which then I write it on the screen. Number one. Question number one. Question number what?
One.
Number one. That's saying simplify. They've given us 27 to the power a third times 16 to the power 3 over 4 over 9 to the power half. That's the question they want us to do. Members, what do we do there? This is indices. This is what?
Indices.
So what do? We have to express numbers in power form. We have to express numbers in power what? So the first thing you have to express numbers in the form, a to the power what? N. Where a is our base, then n is our power. So now when you look at 27, what is 27? 27 is the same as 3
to power 3.
What about 16? 16 is the same as 2 to the power. And 9 is the same as 3.
2.
Now we have simplified them like that. Now we put them back. Why do we put it like that? Because indices deal with powers, members. Indices deal with what? Powers. Because that one we are expressing numbers in power form or in index form or in indices form or in exponential form. Okay? Now after simply putting them in power form like this or in indices form, now we come and replace them back there. So it implies now our 27, which is 3 what? Cube will be raised to the power a third. I think that time, open a bracket, 2 to the power 4, but raised to the power 3 over what? 4. Over 3 squared raised to the power what? A half. Members, which laws should we remember from here? If you recall, recall, we said if a number is raised to another power, what do we do to the powers?
Multiply.
So if I have a to the power m, again raised to the power n, this number is the same as a to the power m what? Mn. So that's the law we are going to apply there. So which means I'll have 3 to the power 3 times what? Times a third. Time 2 to the power 4 times what? 3 over what? Over 4. Over 3 squared times what? A half. Have you seen that?
Yes.
So you find this 3 will cancel with this 3. This 4 will cancel with this 3, with that 4. This 2 will cancel with this 2. Not so?
Yes.
You find that you remain with what? 3 to the power 1 times 2 to the power what? I mean 2 to the power 2 to the power 3 over what?
3
Over
to
3.
the power 1.
So we have in a number raised to power 1 is that number, not so?
Yes.
Time 2 to the power 3 divide by what? 3. Do we stop there? When you look at this,
No.
there's a common factor there, not so?
Yes.
Which means this 3 will cancel with this what?
3.
Then you remain with what? 2 over?
2 to the power 3.
But what is 2 to the power 3? But 2 to the power 3 is what?
8.
8.
Is 8. So which means therefore our answer is what?
8.
8. Have you seen that?
Yes.
Members, are we moving on the same track?
Yes.
Yes, teacher.
Azumta Liz. Nyatho.
Yes,
Nyatho,
teacher.
are we moving
Yes,
together?
teacher.
For you join the platform late. Are we together now?
Yes.
Good. Who also came late? Ipido. Ipido also joined late when we have already started this topic. Ipido, are we together?
Yeah, we're together.
Good. Who else came late when we have already started this concept? Yes. Gabriela. Nisi?
Yes,
Nisi,
teacher.
are we together?
Yes.
Are we together?
Yes.
What about Otim?
Yes.
What about Otim? Otim? Reddy has been
Yes.
there. Reddy has been there. Sonia, I think you have been there when I was starting this topic. Okay. Let's move to number 2. Question number 2. Let me look for another one here and we try it out. Another one. By the way, members,
Yes, teacher.
I've also got
teacher.
I've got this one also from logarithm. Can we look at it also? This one is from logarithm, but not like
Yes.
it's not like the one we were doing, not application of logarithm. Okay.
Yes.
The question is saying without using tables. Now the other one we were using table. Okay. Without using
Yes.
tables or a calculator. Sorry, without using a table or a calculator, comma, evaluate, that said 2 log of 5 plus log of 4 minus log of 0.1. 0.1. Have you put it down?
Yes.
Remember, here what should we put into perspective? We must remember the laws of what? The laws of?
Log.
We must remember the law of what? Logarithm.
Logarithm.
And how many operations are we dealing with it?
Two.
3.
Okay. So now, if you recall, we said if a number, if you remember the power law, the power what?
Log.
We said if I have log to base a of b again raised to the power n. What does the law say? The law said we can put it n into log of a. I think that.
Yes.
Do you remember that?
Yes.
The law also said if I have log of a of b plus log of a of c, what do we do to the log? To get a single logarithm, we what? We multiply them. The law also said if I have log of a of b minus
log of a of b
the law,
minus
What do we get? We get log of A. What do we get? We get log of A. B over what?
Teacher, like is poor.
Yes?
No, it's someone.
Who is that one putting Pastor Mujingo on the background? Members?
Yes.
Is it okay now?
Yes, teacher.
Is it okay now?
Yes.
So if you are adding, if you are adding logarithm, you multiply. If you are subtracting, what do? You
Divide.
and the reverse is true. And the reverse is what?
True.
Is true. Now our question is 2 log 5 plus log 4 minus log of 0.1. What is the base of this logarithm? Remember, what is the base?
1.
Base 10. Base what? That one we call it common. Is common what? Common logarithm, which means is to base what? The log is to base 10. Which can be written as just log. When you see any question just written log, just know that that log is to base what? To base 10. So now if I simplify that, now if you remember the first one, what does it, which means I'm going to bring this power what? In front. So which means this one will give us 10 log, to base 10, which there's no need to write that. So 5 to the power what?
2.
This is the power. So which means you come and write it there. So plus log of 4 minus log. Members, this is a decimal point. This is a decimal what? This is a
Point.
This is a decimal. There's someone, I don't know who is that person, please. There's someone who is that person. We know that 0.1 is the same as what, members? 0.1 is the same as 1 over what? The same as 1 over what? 1 over 10. So which means this one will give us log. What is 5 squared? 5 squared is 20.
5.
25 plus log of 4 minus. Members, what are we doing here? Here we are dividing. We are what?
Dividing.
And when we are dividing logarithm, what do? We what? We subtract, not so?
Yes.
So this one will be the same as log of 1 minus log of what? Of what? I'm just simplifying this one. I'm simplifying this one. I think that because we don't want to deal with decimal point. Okay?
Yes.
Because they have told us not to use a table or a what? Or a calculator. So when we have that, so which means this is the same as log of 25 plus log of what? 4. Now I open this bracket. So it become minus what? 1. Negative times negative will be what? Plus. Plus what? Plus a 10. Plus a 10. But members, if you recall very well, what is the log of 1? Recall. What is the log of 1? Log of 1 is what? Just pick your calculator and press for me. What is the log of 1? Press for me log of 1. Log of 1, what do you get? Is it not 0?
0.
Yes. That one is what? Is 0. So which means we remain with, so it implies now we shall have log of 25 plus log of 4. This one is now 0. So there's no need of writing it plus log of what? Log of 10. But if you also remember very well, what is log of 10? Log of 10 is what? What is log of 10? Press log is 1. But for that one, we can first leave it like that. We can first leave it. So now, let me say log of 25 plus log of 4 plus log of what? 10. So we are having now only one operation, which is what? Addition. Which is what? Addition.
Addition.
So what do we do to the log? To get a single log, what do? We what? We multiply. So it will be 25 times what? 4 times what? Times 10. I think that?
Yes.
Which will give us log of what? 25 times 4, that is 100. 100 times 10, that is one what?
1,000.
That is 1,000. Do we stop there? Members, do we stop there?
No.
Come and say, but this one can still be simplified further. But 1000 is the same as what? 10 to the power?
3.
So which means it implies now log, because this is to base 10 of 1000 is equals to log to base 10 of 10 to the power what? 10 to the power 3. Which from the first line, now this one is the same as log of this, that. Have you seen that? But log to base 10 of 10 is what? 1. The same base. As long as you are getting log of the same base, that log must be 1. Even if the base is 2 and you're getting a log of 2, but the base is 2, that log must be what? 1. Okay?
Yes.
So now it implies now, Mr. Love. So log, okay? Log to base 10 of 1000 is equals to 3 times what? Times 1. So which means our final answer is what?
3.
Members, have you seen that?
Mm.
Yes. Good. That is 1. We are just revising. We are just what? Revising. How do you rationalize surds? There's also, I've got another one here, members. I've got another one here, still under indices. This question is saying simplify 5 to the power x plus 1 times 5 to the power negative 2x, everything divided by 5 to the power negative x. Have you seen that?
Yes.
This is what? Indices. This is what?
Indices.
Indices.
And we said the law of indices is only applicable if the numbers we are dealing with have the same base. If they have the same what? Base.
B.
Like when you look at our method, they have the base of 5, they have the base of 5, they have the base of 5, which means the law of the law of indices is applicable. The law of indices is what? Applicable. And we are multiplying. What do we do to their powers? I said if I have a to the power m and I'm multiplying a to the power n, what do we do to their powers? We add. We add the what? We add. So now this one will be 5 into x plus 1 plus negative what? Over 5 to the power negative x. Members, you are in a class. You are in class, please. Tell people who are around you to know that you are in class. So what do we get here? So this one will give us 5. Will give us x, will be x minus 2x plus 1. Not so? Divide by 5 to the power negative. So this one will give us 5. This one will give you what? What do you get there? X minus negative x plus
1.
What? Plus 1. Divide by 5 to the power x. We are dividing. And if you're dividing and they have the same base, what do you do to their powers?
Subtract.
We subtract their powers. Good. So which implies that we shall have 5 into negative x plus 1 minus into what? Remember this one? Into negative what? Negative what? X, like that. So which means we shall have 5. Open this bracket, we shall have negative x plus 1. Negative and negative will give us a positive, which will be plus what? Plus x. Negative x plus x, what do you get?
2x.
Are you for real? Negative x plus x
0
is 0. So which means we have 0. 0 plus what? 1. So now this one will give us 5 to the power what?
1.
And any number raised to power 1 is it? Is that number? So which means our answer is what? Our answer is 5. Members, have you seen how simple it is? Have you seen that?
Yes, teacher.
Members,
Yes,
Yes.
teacher.
this is your trial. Work out these ones, okay?
Yes.
Work out these ones. Exercise. Exercise. Now this one is combined. This is what? Combine.
Come.
Use logarithm. Use what? Logarithm to evaluate. Use logarithm to evaluate the square root of 0.0000692. 69 what? 92. Members, do you remember this? This application, right? Number two. Given that log to base 10 of 12 plus log to base 10 of 5.
Teacher,
Yes?
the number one, this part isn't clear, you see. Now I can see it. It's complete.
Okay.
I'm good.
Good. Minus log to base 10 of x equals to log to base 10 of 20. Find the value of x. Find the value of what? Of x. Who has finished number one? Three. Simplify 3 to the power n times 9 to the power n minus. Yes? Yes?
The paper the other side, you don't see it very clearly. I'm putting it.
What about this? Are you seeing it well now? Members, are you seeing it well?
Yes.
27 to the power n minus 1. Number four. Let me get one for Surds. Rationalize root of 2 over root of 3 plus root of 2. Okay? Members?
Yes.
I think these are enough. How many questions have I given?
4.
4.
4 of them. So work it out, please. Who is writing, please? What is this person trying to do? Please, can you? So I think that marks the ends of indices, surds, and logarithm. Okay? So next time we meet, we shall have a new topic. Please don't miss. Okay? But you must submit this one before Monday. Before what?
Monday.
Okay. Okay, members, have a good day, please.
Okay. Thank you, teacher.
Okay, members.
Teacher, bye.
Bye.
Thank you.
Bye.
Bye. Bye.
Thank you for attending. Members, thank you for attending.
You're welcome.
Bye.